paramagnetic. So you're with the magnetic field. You like it, you'll be attracted in.
So the diamagnetic would just be anything that ends, basically kind of like the noble gas.
You got something full, yeah, yeah. You have everything is paired up.
Have we gone over that yet?
I believe I kind of used those terms, I just kind of threw them out as an aside. I didn't write them on the board. There was a section in chapter 4, and it was just paramagnetic, diamagnetic, and I didn't write it out. I just said,
I just wasn't sure.
if you have an unpaired, you're paramagnetic. You're with the magnetic field. You'll be attracted. That's why when you have an not an NMR, that's what we call it in science. In medicine, it's MRI. Same thing, bigger sample when it's for humans. When you have that, they're asking you, like, what metals do you have in your body? Because most of the metals, not 100%, but most of the metals are paramagnetic. And so, if you have, say, a piece of shrapnel in your body, that's going to be so attracted to that magnetic field, that's going to kind of try to rip it out of your body. Okay? And if I told this story, somebody give me a polite hand gesture. You can be killed in there if some fool comes into the room with, say, a pair of scissors or an oxygen tank, that a regular old oxygen tank, that's going to be like a missile flying through the room. One of my students worked as I always say it backwards because MRI is the chemistry talk for the same thing. But somebody came into the room when she was working as a technician, and they had scissors, and she said a pair of scissors flew by her head and then latched onto the magnet, and they had to crank the magnet down in order to get the scissors off the magnet. It's strong, really strong. So you don't want to go in with metals on at all, and have metals in your body. I've heard, if you have a tattoo, because evidently there's some metal in the ink in tattoos, you'll heat up. It's not going to rip your tattoo off your person, but that part of your body is going to get warm.
Yeah, if you have a color tattoo, you're not allowed to have it in it.
Oh, really?
Yeah.
Okay. Well, I did not have that problem, so.
They either don't do anything, they just go in and do surgery. Because I've had knee surgery before.
Oh, okay.
That was one of the questions they asked me, and I asked them why. I said, because if you have a color tattoo, the metals are too strong from the dye, and you're not. Okay. It might kill you. Like, it's killed somebody before. Like, if you had a lot of tattoos, like, you know, people have a lot of tattoos on their body, it could
A good argument against having them, because you have a NMR, or MRI, pardon me, I cannot get those letters straight. MRI, a lot of times that can save you from surgery, or it lets your surgeon know exactly what needs to be done instead of just opening you up and it's exploratory. So it could save your life not to have one, because if you could have that non-invasive procedure, that would be better. Okay, let's get back to the point here. So we are paramagnetic because we are attracted into a magnetic field with those unpaired electrons. Okay, now, this is a very ambiguous question for copper or for chromium, okay, because of it being an exception. And so I tried to pin it down a little bit better for you. Instead of just saying, like I could for titanium, Andrew, I want the 4 quantum numbers for the last electron in titanium. Then it is not ambiguous. You know, you end up with titanium as 3d2. So it would be that second D electron there that we would do the quantum numbers on. But I want the quantum numbers of the last electron of copper, the one in these sub-levels. So I want to come over here. Let me get my circle off of that. Okay, just to make it hard, okay, when Emily gave me this thing, she was going for the D. When she finished up, she was going for the 3D. Up, 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 down, 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 down. So the last thing she said to me was that guy right there. Okay, because we just fill it straight across. So remember your quantum numbers. It's kind of stuff you already know. It's just taking a different angle at it. When I said And this is a big point for students to be sure you distinguish between these two big things. I say, let's go do the electron configuration for copper, or for anything for that matter. We try to tell folks something about every electron there, all 29 of them. Okay, if I talk about quantum numbers, we're talking about one electron. Within an atom, each electron in that atom has its own address, or its 4 quantum numbers. Now, if you are a copper here, and say you're a zinc here, a lot of the electrons in zinc are going to have the same address. But if you're talking, you're within copper, then everybody has its own address within that one type of element. So, let's see what we can do with that. And let's see, let me make some room here. Let's list the 4 quantum numbers. The first quantum number is called what, Hina? N. Okay, our second quantum number, Marco, is called?
P.
L.
No. L.
L.
Yes, that's right.
Yeah, L. Lowercase l. Meredith, what's the third quantum number called?
M with a sub.
Okay, and our fourth quantum number, Nikki, in the third row?
That's where it's like the, I don't remember what it is, but it's like the
S.
half.
Okay, you got the values, but what do we call it? What's the, like the designations here, what's our fourth one called, general case? Other Nikki, can you help her? M sub S, S for spin. Okay, now let's take that electron that I've got circled over there. And this is probably the hardest part because it's the newest part. Pedro, what's the N value for that guy?
3.
Okay, why? Defend that.
Because it's in the major. What is it? The major level.
Yeah, it's on the third major level. Now, it is immaterial that we got an electron out there playing games in the fourth level. Because I'm not asking about that. I'm asking, that electron I circled, what's his address? He's on the third major energy level. Okay, so that's L. N is 3. Sarah, what's M? Or pardon me, what is L?
I'm crazy you're going to ask me that.
I read your mind. See, I knew there was fear lurking there. Do you remember the little code that we had? I said it's just like playing games as a child, where you have a code. In the old talk, our sublevels went S, P, D, F, and so forth. You know, sober physicists don't find. Okay, new talk. This is the old, this is the new. We had a code. If you remember what it starts with, no sweat. What's L if we're
Oh, 0.
0 and then
1.
okay, now answer my question. 2. Because it was 1, 0, 1, 2, 3. How are you going to remember that? An S sublevel has S orbitals, and we know they're spherical. And if you wrote a sphere on the board on a flat surface, it'd be just a circle. So it's a 0. And I know that's kind of a stretch, but that'll let you know where we start. Yeah,
Sorry, going back to N, you know it's 3 because it's 3D?
it's on the third major level, which it's in the 3D, so that means it's on the third major level.
Okay, what if it was like 4S? Would it be?
Well then, N's what?
Could it be 4?
Sure.
Okay.
Okay, now, M sub L I think is the trickiest one of all, and that tells you about orientation in space, and that's where the box diagrams are really valuable for this, because if I went ahead and made them as boxes for your M sub L, that's where you build a number line. Okay, so tell me how we would do that. Marco, do you remember?
Yeah, you should put a 0 right in the middle.
Okay,
To the
and?
left, you put a -1.
Okay.
And to the right, you put a +1.
Okay, and then -2, +2,
That's right.
and that's unfortunately kind of messy, but you got the idea. It's a number line. It's just to designate which orbital we're in. So M sub L for that guy, Tanya, is going to be what? It's right up above the box. We're talking this guy,
Oh, +2.
+2. Okay? All right, we did okay? Now, M sub S, Nina,
Is it negative half?
yeah. And why is it negative 1/2?
Because it's the second one?
Yes, the
That's
second
one on
guy
the
in.
right.
Okay, his roommate, same orbital. How does the roommate's address vary, Brittany?
The M sub S, it would just be 3, 2, 2, positive 1.
Yeah, the first three would be the same. Because as you see this address, and I talked about, you know, your name, Houston, Texas, God, a bunch of people share that. Okay, so here, if N is 3, we know the major level. If we know this, then we know which sub-level. So I always, when I'm working problems like this, I translate, especially those first two. I'll say, that translates to the old talk as 3D. And then I'm on firmer ground because I understand, or I work with this kind of 1S2, 2S a lot more than with this. Okay, we survived that. Now, another section in chapter 4 was to talk about families, periods, metals, nonmetals, and metalloids, because we can't memorize info about every one of those guys up there, but if you have them grouped, you can understand it better. And so, with copper, if I say, what family is that in there, Tran? Can you tell me? What family? 1B. All you have to do is look up above it, and it does not have this particular family, and I've lost my pointer. Anybody see where I laid it down this time? Oh, thank you. Okay, some of these families had special names, but the 1B, which is what Tran just told us, it doesn't have a special name. Some of them have old-fashioned names. Let's go back. 1A, what was the old-fashioned name for that?
Alkaline.
Alkali metals, okay? And what was the old-fashioned name for the 2A?
Alkaline.
Alkaline earth metals, usually. What's the old-fashioned name for the 7A? Halogens. And I think I told you all a lie last time. I pointed at these and I said they also have some old-fashioned names, and I said actinides and lanthanides, and I had those backwards. It's out of alphabetical order. Those are the lanthanides. It's on your periodic table. And these are the actinides. May I show this? Let me flash this for you.
Which one is the halogen?
7A.
There. Down here where we're filling the F. And look what Tran has done to her periodic table. She's desecrated her periodic table here, but it's great to study with. Now on test days you can't hold that in with her, but it's a fantastic way to study. She labeled those as 4Fs. She's put these as 5Fs. And here, for the ones filling into 4F, that's the old-fashioned name, lanthanide. And then actinide, just like we have some other old-fashioned names. But when I said this Thursday, I'm sure I said actinides and lanthanides, and I went like that and probably led you astray. So let me give back your wonderful study guide there. Okay, so we have, it's the 1B family here. Then if I want to know what period that is in, what period is that in? Fourth. It's in the fourth period. And remember, the period idea is totally independent of electron configuration. So period, you count down the side, 4, fourth period, all the way across. Even though you know you're filling 4S and then 3D in material, this is just a simpler idea. So we're in the fourth period, and then the final question here. Antonio, are we a metal, a non-metal, or a metalloid?
Metal.
A metal. How did you know? If you were just looking at, let's say you've never heard of copper before in your life.
Because it's the metal.
Okay, it's, see the jagged red line? It's to the left and down. And metals, do they tend to gain or lose electrons? Lose. And become what? Cations or anions?
Cations.
Cations, all right. Now, right at the end of the hour, we talked about section 5-1. And I said there are some other ways to categorize. And usually this is put into multiple choice format and list them and just say which one is it. So we have Sometimes it's referred to as 8A, but the name for it, and I suppose you would say the old-fashioned name, the noble gases are right there. Would they be paramagnetic or diamagnetic? Diamagnetic, because noble gases have a full subshell, and that's fantastic. It confers a lot of stability. That's why they're so stable, they don't tend to react. Okay, then we had representatives, we had transition, and we had inner transition. So if I say representative elements, before you answer the question about copper, let's review. A representative element, does anybody remember? Alex, do you remember? Okay.
1A through 7A.
Exactly, 1A through 7A. Occasionally in books it's just going to say the A families, but that's kind of a lie, because 8A are not representatives, they're noble gases. So 1A through 7A to be more specific. Representative, we call them that because they're so predictable. And we work in this class, I would say at least 80% of the time with representative ones because they're predictable as far as will they gain electrons, will they lose, how many will they do. So representatives are the 1A through 7A. Transitions here. Allison, do you remember? The B families. And then the inner transition, this last, Russell?
The bottom one.
The bottom ones, the lanthanides and actinides, are where we're filling the F's. Okay, back to the original question. I've got copper, so Antonio, which must it be?
Transition.
Transition, exactly. Now that is reviewed in, what, 35 minutes. We reviewed all of Chapter 4 and the first section in Chapter 5. So if you can do that, you've got Chapter 4 nailed. But, word of warning, this is your coach talking. Because you could follow it and agree, oh yeah, that's right. Following it is your first level of understanding. Doing it yourself is where you have to get to. So that's the next level of understanding. Follow it first and then go do it. Take a blank piece of paper and answer all those yourself. Okay.